Hello everyone, I am Jose Paulo de la Cruz. I would like to share to you my project about the development of an experimental science module to improve middle school students' integrated science process skills. A holistic view of 21st century teaching and learning focuses on the discrete combination of 21st century student outcomes with innovative support systems to help students master the multidimensional abilities required of them in the 21st century and beyond. The purpose of science education today should be aligned to produce a support system that produces 24th century outcomes for today's students. Science education should focus on the development of scientific literacy to enable understanding of the nature of science and its relationship to society, rather than a focus that is heavily weighted in content knowledge. Learning sciences should develop students as inquirers, scientifically literate, caring, and responsible individuals who will think critically and creatively when solving problems and making decisions about aspects affecting themselves, others, and their social and natural environments. It is more than simply learning technical scientific terminology. To learn science in the 21st century, students are expected to demonstrate critical thinking skills, to analyze and evaluate information in order for them to make informed judgment in a variety of contexts. This can only happen by providing students with opportunities to explore the connections between science and everyday life. As such, students are able to gain insights into the tensions and dependencies between science and society. This simply puts inquiry as the heart of learning sciences. It aims to support students' understanding of sciences by providing them with opportunities to independently investigate relevant issues through both research and experimentation. The use of open, student led investigations alongside scaffolded teaching of research skills and the integration of science process skills allows students at all levels to learn what it means to do science, solve problems, and develop thinking skills. Notably, these foundations are important for students who are going to continue science, as well for those who will not continue beyond secondary school. A science investigation emphasizes the use of the scientific method in performing an investigation by experimentation. Thus, science investigations are giving students an opportunity to undergo the process of conducting an investigation using the scientific method, making students gain a considerable understanding of the nature of obtaining solutions and problems or answers to questions in a systematic and scientific way. Science processes skills are a set of broadly transferable abilities appropriate to many science disciplines and reflective of the behavior of scientists. Science processes skills have two types: basic and integrated. The basic or simple processes skills provide a foundation for learning the integrated or more complex skills. The basic science process skills are observing, or the use of the senses to gather information about an object or event; inferring, or the making of an educated guess about an object or event based on previously gathered data or information; measuring, or the use of both standard and non-standard measures or estimates to describe dimensions of an object or event; communicating, or the use of words or graphic symbols to describe an action, object, or event; classifying, or the grouping or ordering of objects or events into categories based on properties or criteria; predicting, or stating the outcome of a future event based on a pattern of evidence. On the other hand, the different integrated science processes skills are controlling variables, or being able to identify variables that can affect an experimental outcome; defining operationally, or stating how to measure a variable in an experiment, formulating hypotheses, or stating the expected outcome of an experiment, interpreting data, or organizing data and drawing conclusions from it, experimenting, or being able to conduct an experiment, design a fair test, conduct the experiment, and interpreting the results of the experiment. And lastly, formulating models, or creating a mental or physical model of a process or event. These science process skills can be learned if taught formally in the classroom with the use of proven teaching methods. Furthermore, these skills can be retained for future use if lessons are based on science investigations and practice over a long period of time. Thus, a 7-week learning module was developed, intended mainly for grade 7 and grade 8 students to give them a beginning knowledge of scientific writing. This module aims to support students' understanding of sciences by providing them with opportunities to independently investigate a phenomenon through both research and experimentation. This experimental science class aims to expose students to various science investigations chosen by the teacher. Each class followed a 7 week research-developed curriculum and meets 7 periods in a week. This experimental science module emphasizes the use of the scientific method in performing an investigation by experimentation or by inquiry-based learning to develop critical thinking skills and science process skills of the students. The developed experimental science module was designed to help students understand the basic aspects of scientific inquiry and method by determining the steps of the scientific method, and to provide students with an opportunity to practice and refine their critical thinking skills by developing their integrated science process skills. This module also enables students to participate in activities that integrate inquiry science, physics, chemistry, and biology. As such, they need to be exposed to a variety of measurement and laboratory techniques. The context of the module's classroom lessons are engaging. Students are expected to showcase the science process skills they have gained through coursework and laboratory practicals. To culminate their learnings, students are expected to write a full investigation report. To determine the effectivity of the developed module, an integrated science process skills test was administered to students before and after they finished the module. To identify students' mastery of each process skill, an item analysis was carried out for each item in the test. The figure shows that the performance of the students in each skill tested through the integrated science process skill test. It can be noted that even before students went through the module, they already have at least a proficient level of the integrated science process skills, except for stating hypotheses, where they only have a skill level of developing proficiency. It can further be noted that 8% of the students learned the skill of identifying variables, 11% acquired the skill of stating hypotheses, 16% learned the skill of operationally defining variables, 8% acquired the skill of graphing and interpreting data, and 14% learned the skill of designing experiments. Overall analysis of student proficiency level revealed that more students after going through the 7-week module reached advanced proficiency. Comparing pre-test and post-test scores, 66% of the students learned positively from the module. Statistical analysis of students' overall scores showed that students of the experimental science module significantly improved their scores in the integrated science process skills test. It can be inferred that students exposed to the experimental science module had the opportunity to identify variables, state hypotheses, operationally define variables, graph and interpret data, and design experiments as they involve themselves in the science investigation activities. There were some challenges encountered while teaching the module in the actual classroom, such as the 7 weeks are not enough to allow students to master all the skills. Also, students have difficulty researching and evaluating sources of related concepts. And the quality of students' laboratory report still needs improvement. It is important to note that the success of the approach may depend on the competence, enthusiasm, and confidence of the science teacher and the ability of the students in making use of the opportunity provided. Student generated questions play an important role in inquiry based science classrooms. However, science teachers know how to use students' questions to guide instructions. It is therefore recommended that for use in the classroom, there should be a scaffolded teaching of each skill. Also, allow the students to have more opportunities to be engaged in doing investigations. Further research is needed to compare results reported in this study to other inquiry based programs. For future studies, it is recommended to determine the impacts of the module on students' streaming choices, and also to examine the correlation among students' interest in science, their understanding of science, and their science process skills. I would like to end my presentation here. Thank you very much for your attention.